This is very far outside of my field. I study Titan's atmosphere, so this might just be ignorance, but I'm wondering if there's been effort to compare similar when you're looking at like gaps in the data, gaps between observations, to compare similar observations. So you mentioned like using GPS temperatures,
Right.
but I think like I know too, I guess like you're looking at like 5.3 micron emission or something like are there other I'm guessing there are probably other satellites that look at similar wavelength bands or
So it's a good question. And I mentioned about the Earth observing system satellites. And so when those come down, there's a whole community that's been built up over the last 30 years with those. It's going to have data. So there's a great effort in that community now to find out what can we use for proxies or what can we use to stand in. But typically, the only thing that's been measured extensively and in many different ways has been ozone because of its importance. Well, because of its importance to everybody out here. And so, but as far as something like SABRE, it's the only thing like it. Even though the ACE instrument measures temperatures and so forth, but it operates on a solar occultation, so it doesn't get type of global and local time coverage that we have. So all the instruments kind of have a different strength and what it's do. But we don't have similar or instruments that make like ozone the same measurement or that make things like this. Maybe in the future we will as it becomes clear what we need to do this geospace observing system. But right now we don't have a lot of proxies or things we can just substitute right away and know we're going to get the same thing. So,
yeah, I guess sorry, I'm thinking more like just to help compare like instruments on different satellites that are not
right.
overlapping.
So again, with the
I guess
so that's right.
because then the coverage doesn't matter necessarily if you can compare the measurements of the like to compare the sensors themselves rather than to like substitute like the data exactly.
Right. So there is that. So like the R satellite that I mentioned with microwave lens stuff, they measure temperature, ozone, and water, and SABRE measures temperature, ozone, and water. And so we've done a lot of comparisons between those, and they're not identical, and we think we understand most of the differences between them. And so so there are some of those cases, but it's not for everything. The biggies like temperature, ozone, and water, those apply for the stratosphere. Those are the first three things you would measure. That's what MLS was focused on, and we also have a stratosphere SABRE, so that's why we have those three. But other than those things that with almost always measure, there's like the 5.3 micron. This is the first time it's been measured globally in space like this, and some of the other things we've measured on several ways, but we just don't have this. Even though we had, all these different satellites, many of them measure temperature, for example. And how many ozone measurements did you compare? I think like 10.
Yeah, there were about 10 that had some overlap.
Had some overlap over. But in general, the way science works is that if everybody proposes a specific science thing, and then unless the science really overlaps, you don't get the same measurements except for those common things like temperature that everybody can measure. So it's a good question. We just don't have that kind of back and and I was surprised in the climate world that I mentioned, because everybody outside my hall at Langley does climate in the lower atmosphere, but there was really only one measurement of that. They had many different instruments over time, but there wasn't like ozone where there's 10 sensors measuring ozone. There's only one sensor measuring the Earth's global energy budget. That just floored me when I realized that, because that is another thing that we all depend on and making sure that's right. I thought there would have been several people measuring that, or several people, just one. Which one is that? That's a series instruments. And last is building Libra, which is going to be the successor to series. Next, I forget when launch is going to be on 26 or something, or 27. And they're in that case, they're pushing very hard to get overlap because of this whole issue of calibration and not knowing, yes, they're going to doesn't mean they can't calibrate it, but it's going to be calibrated by a different group, a different calibration system. Everything's going to be different than all the 6 series instruments that preceded it. So they've got to be overlapped in order to make sure that ideally they'll be perfect, right? But if not, then they have to figure out how to tie them together. In the series, so successful ones, they've overlapped them so they can make a continuous record.
Regarding GDC and dynamic, neither one of those has an infrared sensor on them.
GDC won't because it's. So I was on the nice mission team, so we didn't talk about anything in situ for GDC.
Yeah.
Dynamic is starting, all the proposals get in, so I don't know what was proposed. And I would assume, however, that there'd be some sort of infrared sensor. Yeah, but I don't know, because it's, again, it's going to all be focused on the science. And if, I don't know. Have to wait and see if options are and how that's developed in the next few years.
Yeah, and I guess another comment about, you mentioned the A train and how precise their orbit had to be. I know one of the controllers of that system, and were constantly battling essentially space weather and getting, trying to get F10.7 regressed correctly into their orbital neutral density models to plan their orbital maneuvers to keep it that precise, with a lot of work to do that. So one of the things to think about is if you have a science mission in the future that needs that kind of precision of the orbit, it's likely going to get more challenging, as you're going to A, be dodging more stuff, and B, the solar cycle looks like it's trending up, the Gleisberg cycle. So it's going to get lots more interesting for operators of those sorts of.
I think that the orbital consideration could be the driving factor in cost.
Yeah.
Future, for especially if you have a long term, if you want to really make a long term record, that could probably be the driving factor.
It's a really big deal for them to move the satellites for debris avoidance, because they have to get back to that precise orbit and have to move it very carefully so they can get back to that precise orbit. It's not like a commercial satellite where they can just move it and leave it. They have to get back to that orbit every time. So that science mission was a really good, I think, probe of the difficulties of operating in LEO. And now, as it's getting more and more crowded, he was saying they were doing potential orbital maneuver evaluations every week. They don't move it every week, but it used to be every few months they would do an evaluation of a critical conjunction warning. And now it's every week. So it's becoming a full-time job just to do the debris avoidance missions.
I know the space station does the same thing.
Yeah.
They have to move that often to, just to avoid potential debris. I don't know what their bandwidth is and how much, they probability they take, but they have to put that on, and sometimes substantial to avoid something that might be coming their way.
Yeah, it's surprisingly low. It's typically 10 to the -4. The probability of collision is 10 to the -4, or one chance in 10,000 is when they make a maneuver. So they start out at lower probability, then it gets closer and closer to that critical point. And I mean, it varies. Sometimes they won't make a maneuver at 10 to the -4, but that's generally the level at which they really start to work on a maneuver plan. That's surprisingly low probability of collision, if you think about it, but that's how careful they have to be with that system. And that's happening more and more. So yeah, it's cool.
And more and more and more as time goes on. So that was forward when I at the Calcom on the center said 400,000 satellites in 10 to 15 years. Everybody was successful. Everything else. That would just be, I don't know. It might be dark at night. So, okay, well, thank you all again very much.
Yeah.
Please come see me. Science and Business Chat.